Alright.
Come on, Bob, you got it.
Alright, today.
Let me add a slant.
Alright, today, we're in that second section still of chapter 3. The second section was based on logarithms. Logarithms. Alright, so this is the one we started. Today we're going to try to do some things that will help us avoid having to use a calculator in certain cases. So I'm going to try to show you some shortcuts that I've kind of learned over the years of doing this that use some basic properties of logarithms to help us out. Okay, so here's the idea. The goal today is I want to start with talking about exponential form versus logarithmic form. There's a big thing here that we need to understand, like the difference between these, why one is useful, one is definitely helpful in certain cases. But I want to talk about those, do a couple examples today, and then maybe finish with just a few properties about logarithms. It's very easy notes, like I'm not going to go very in depth. I have a couple problems per problem that I would like to cover to make sure that you kind of understand all the basics. And then we'll probably finish there. And then what I want to do is today is maybe throw up the review, the quiz that we took, the test that we did last week, and put the review on the board so you can actually see it. So I'm going to hand those back out. I know you guys turned them in. You guys got to look at your scores, but I want to go through like what the answers were so you can see why you missed it. So, because I didn't do that last week. So,
What were your thoughts? Were you happy with your grades?
yeah, there was some good scores in there. So, especially because I was kind of nervous when everyone's like, "Oh, it's taking me 3 days to finish it." So,
It took me 4 days.
so yeah. So, all right.
Well, Haw,
There's lots of
quit
good-
lying.
lots of good.
Don't lie, Haw.
Okay. All right. Hey, let's go through a couple things here. So first of all, let's talk about exponential form. I'm just going to pick one of these problems out to talk about it. So okay, let's do this.
Another 3 to 5 on Wednesday.
I heard.
All right.
4 to.
This this problem is exponential form. Okay, it's got exponents, it's got numbers, variables. It really doesn't matter. I don't have any variables on mine. But this is an exponential form problem. It's got numbers and variables in certain spots. So usually what we see is like problems like that. We've seen it where we've done problems like this before, where they have variables and numbers in different spots, and we can solve it. Like if it was this problem, the trick is you take the 4th power to the other side,
Oh,
and
yes.
you do the 4th root of 625, which typically turns out to be positive because that's just what it looks for.
Yeah.
Like that's the
Even
style of
percent.
problems. Yep. Okay, so that was an exponential problem. Now, if we went to this problem that I did earlier, let's put an X up here to 625. Now, this problem is substantially harder, significantly harder. Maybe that's a better word. It is way more difficult to figure this one out, other than knowing the answer. Like you have to guess and check numbers
You can log it.
that make this work. Okay,
4.
you can guess
Try 4.
1, guess 2, guess 3, and you guess up until you get to 4, where 5 to the 4th power is 5 times 5 times 5 times 5, and you get to 625. Like you could guess it until you get there. Now the problem is, what happens when the numbers don't work out perfectly? Like where
You start guessing decimal.
yeah, where it's 5 to some power, but I need to make 700. Okay, that's not a pretty number, right?
4.3.
That it's gonna be some weird number, and this is where the difference between like this type of math, where you want to use a calculator for that one, like that's where the logarithm comes in. When you can't actually guess what power it is, but you can use that calculation on your calculator to help you figure out what it should be. Okay, so this problem right here is why we have a logarithm. Because we do this method called the circle method to convert it.
Who created the circle method?
I have no idea. It's just something I was taught in school. I didn't really ever have the history of like a logarithm. I can figure it out. I'll let you know.
All right, I need the history on everything.
I'll give you a little bit of history fast.
Okay.
Okay, alright. But circle method, what you do is you start with the number above or below, so the base is usually where I start with. You go around in a big circle and you end up with the power. And this will convert it to a logarithm. Okay, so the logarithm itself is log base 5, that's how they say it, of 700 equals the power. Now, that's what a logarithm is. A log on a calculator, like what a logarithm is used for, is to find the power on a number. So the exponent.
4.07.
Okay. Alright, so when you actually type this in, some people can just type that in where they can type in the little 5, the base number. They can type in the 700. If you can't,
It's because the Casio is stupid.
you can do a quick conversion where the 5 can drop out the bottom, and you can do the change of base where you put the log 5 on the bottom, the
It's like
log
change
700
of
on the top.
base.
Because what I always think of is like the base.
Yeah.
It looks like it's getting smaller. It's like kind of falling out the bottom of the fraction. So it falls to the bottom and it makes its own log. And then this is, what was the number, Josie, that you had?
4.070.
070 kind of thing?
Yeah.
Alright, so that's roughly the number. And it was roughly really close to 4 because 5 to the 4th was 625. So it wasn't a 5. Like 5 to the 5th power.
Mr. Ward, that's not actually precise though.
It's close. It's
You need to
approximate,
use
so.
powers if the things.
That is only 699.53,
Yeah.
which
So
would
we would have got
not
more
round
decimal
up.
places. Can you go 5 to the 5th power? Somebody?
Yes.
3,125.
5,300.
Okay.
That's 3,125 with no decimal points.
Alright. No, hey, look at the difference here. Look at the difference between one power. No, 600 versus 3,000. That's why the answer
I'll find the difference between those.
0.07 made sense.
How much do you have to multiply 625 by to get 3,125?
5.
5. Exactly.
The
Exactly.
difference is 2,500. Wow, that's convenient.
Mr. Ward, do you think I could throw this into that
No.
garbage
Alright.
from
No. Alright. Hey,
I think the angle is plausible.
hey, shh. Now, what I want to show you today is there a way to do some of these problems without a calculator?
No.
Is there a shortcut we could potentially take? And that's what I want to talk about. And it's what this is called changing of the base without a calculator. So this is something that when I first saw it in high school, it made sense. Like there is a way to guess numbers as long as you are willing to kind of try to
Why on earth would we
adjust.
want to do that?
So, all right.
Wait,
I'll
why would
show
we
you.
want to do this without a calculator?
All right. I'll show you.
Alright.
Okay.
But like I'm saying, why would I want to? If I have.
Okay.
I don't think this is really explaining why I want to do it.
Okay.
Let's see.
Alright. Okay.
I bet you I can do it faster on the calculator.
I want to do 64. So 32.
Log 32 divided by log.
No, hold on. No,
No, no,
don't.
no,
Please don't type it in.
Don't take it.
All right.
I'm one button away.
Hey. All right. Hey. So let's talk about these problems and let's talk about how we can calculate this without actually typing in the calculator. Now, just to give you an idea why you would potentially need a calculator.
I did it.
8 to the first is 8.
8 to the 0 is
8
1.
to the second is 64.
Sure.
That's
8 times 8.
It's gonna be
So-
between there, I bet.
It's a number between. Now, let's talk about how do we get to that answer.
It's gonna be like in between because
It's half
it's
of it.
perfect.
Close.
No, that's not gonna work out.
64 divided by 2 is
I already
32.
did
But
it.
it grows exponentially per second.
So it's 0.25.
Hey.
No.
Okay. Without typing this in a calculator, how do we figure it out by hand? So here's what we do.
Yes.
You change each of these numbers, and this is called the changing of the base without a calculator. You change both of these objects to a similar base number. So like for instance, 8 can be written as 2
16.
to the 3rd power.
Oh.
Okay? That's the same thing. 32 is the same thing as I can go 2 to the 5th power.
16 to the second
Okay.
power.
And so the idea is that how you can actually solve this, these can actually multiply together. Since it's a power and a power, so that the laws of exponents say you can multiply the powers together. So that's 2 to the 3x equals 2 to the 5th, right? Well, here's the trick. If the bases are the same, the exponents have to be the
So
same.
then divide by 3.
So the idea is that find your answer.
It's the same answer, Mr. Ward, if you do it on the
Okay.
calculator.
So if you actually change the base, then you can divide this 3 over 5/3. Okay, which in our case would be 1 2/3. So
Which is 1.666666667.
and I wouldn't need I wouldn't need a calculator because I can do it by hand quick enough that I won't need one. Because if you are able to, and you're able to change so that the bases are the same, you won't need to use a logarithm. The logarithm in this case is when I don't know how to change the bases. Like I don't know how to change a 7 to some base of 5 because it didn't work out nice and pretty.
I have a question.
Right? Question.
Are we gonna need to know how to do this on the test?
It would be definitely
There's no test
helpful
over
to know
chapter
it.
3.
Why isn't there a test over chapter 3?
There is. We haven't got there yet.
Oh.
So.
What did you say?
Yeah, if you plug it in like a calculator.
I would definitely say it would help you and it would make your answers faster.
With a
It's
Why
actually-
can't
calculator.
you just use a calculator?
Don't need to know.
Calculator, yeah, you're fine, but I want you to be able to understand like how to do it by hand if you ever need to.
Okay.
I'll just say, I'll put it that way. If you needed to, you gotta know how to do it by hand. Okay.
I'm curious, what is the 66666?
Math placement test where you couldn't use calculator. That's where I need it.
So it won't be on.
So,
You're gonna do that to
I
us?
was gone for a while.
colleges would. So,
Should I not go to college?
Now,
If
hey.
college does that, I'm not paying to it.
Okay, alright, here we go. Next one.
You'll show them, I bet, if you don't pay tuition.
Sorry? I think you look like Ferb from Phineas and Ferb.
Alright, next problem.
Politics. Yeah. Green hair.
Hey, okay, come on.
Mr. Ward, do you think Hogg resembles Mr. Furman?
Discuss is the logarithmic form. We haven't really talked about this. This is a logarithm. If you don't have a calculator on hand and you're trying to find the answer, so let's say we're going back to by hand. There is a way to change this problem back to exponential form, and it's still called a circle method. So, now again, most people, if you have a calculator, you already know the little shortcuts for how to type it in. But if you didn't, or maybe your calculator isn't working right, or you don't know how to type it in somebody else's calculator, you can't figure it out, this is what you can do. You can do a circle method and change it back to exponential. Now what this means, the base is the 2, the logarithm, what this is equal to, it's always equal to the power. This is the power if you're going backwards. Logarithm means power, so the x over here is the power on the base. And then your final answer is the 64. And so the idea is that now that we're back to exponential, we can do that little shortcut that I just showed you a little bit ago, which is going 2 to the x, changing the 64 is 2 to the 6th power.
Okay, but if you knew 64 was 2 to the 6th power, wouldn't you know
Yeah,
the
so-
whole thing?
Exactly.
That's
So
what makes sense.
that's what we're talking about. But there's
log 64
these would be for like different numbers where you have to change. I just picked an easy one so we can figure it out. But this is when they put like say they put like a 9 here. They put like other
Yeah,
numbers.
but like
What?
it's-
where
I
it's-
wouldn't know 2 to the 6th equals 64.
Well, those are things like you'd have to guess if you
Well,
like
see, what I would-
like taking 2 times 2,
I would
like
just take
trying
log
to
64
take
divided by
multiple
log
2s
2
times
and
each other.
6,
Like
right?
those are things you can do off to the side if you didn't have a calculator. You can actually guess at it. I know that's really stretching because most people have a calculator on them. But if you ever didn't, this is a way to do it without a calculator. So, but what I'm doing here is I'm showing you how to go from exponential or logarithmic to exponential form.
Thank you,
Okay.
Mr. Ward.
All right, now 2 properties today. These are being my last 2 today. Last 2 properties. I want to talk about what happens when we have logarithms of certain objects, and then tomorrow we'll talk about 2 more. So here's the idea. First one, log b of b. Okay, there's 2 properties I want to talk about today. This is the first one, and this goes directly with what we're talking about.
B over B.
Okay? No. Okay, anytime you have this on a problem where the log, the base, is the same as the number that's right next to it, what you're evaluating, the answer will always be 1. Okay, here's the
Oh, that
reason
makes
why.
sense, because it's log divided by log of the same number.
Exactly. There's 2 ways to think of it. Number 1, if you didn't hear Reese, it's taking log of the top number divided by, and if this goes to the bottom like we did the change of base, log of b. And so they would cancel out and make 1. That's one way. Second method, it's trying to do this. It's trying to go b, so here, I'll use the b as my example. Okay, b to this power equals this thing. B to the x equals b. Well, the only way that this works is if the powers are equal to each other, because they both have the same bases. So the x would have to be a 1. So these are two different methods you could use to see that it would actually work. Now, the other property is this. I'll just put a variable in here, let's put like a w, and I have a 1 sitting here. Okay, this one is the only other property I want to discuss today. Alright, so on this particular problem, log w of 1, this idea, the answer is always 0. Here's the reason why. No matter what number you type in for w, whatever number you have, you're going to put it to this power, which, in earlier I didn't know what it was. It was an x. So if you do a circle method, so w to the x would equal 1. The only number you could plug in here that would make it 1 is always 0. Anything to the 0 power is a 1. Okay, alright, does everyone have those two basic properties down?
Yes.
Okay, tomorrow we're going to look at 2 more, and then we'll get to homework tomorrow. Now, the homework I'll assign tomorrow, I'll probably do later in the week, Thursday, Friday kind of time frame. Be ready to go on that? Alright.
Sure, do you think Hog resembles Verb at all?
I'll bring up a picture.
Bring up a pic of just